Your video game is all the rage. Everyone wants to play right now. But there's so many users trying to log in from all over the world, and because there aren't enough globally consistent servers close to your players, they're stuck waiting in the lobby. But once they get logged in, it'll get better. Obviously, they want to pick up where they left off, which isn't here. Wrong level. And items they bought are missing. Bummer. What about when they want to check the leaderboard? Another delay? Well, they can just grab their friends and head into matchmaking. Wait a minute. How is this fair? Or fun? You need a solution. Fast. And you'll get that with Redis Enterprise. Redis Enterprise is a real-time data platform for use as a cache, database, message broker, and queue, which is a mouthful, so just think of it like a game developer's ultimate sidekick. Yeah, like a wizard. Blasting latency issues in real time with our epic cache capabilities. Available in cloud or on-prem. You'll now have the power needed to give your users the gameplay they want. At scale, super fast login and session management speeds, even during traffic spikes. Instant access to your inventory. Higher player engagement with real-time leaderboards. Optimized team and skill-based matchmaking. And the ability to connect with friends, leading to higher player engagement. You keep developing games, we'll keep optimizing the player experience with Redis Enterprise Real-Time Gaming.
So thank you everyone for joining. This is a webinar about using Redis as a real-time database to create an amazing gaming experience. It's going to be around gaming. What can you do with Redis to optimize the way you develop your games? Obviously, we assume that you are familiar with Redis, the most loved database according to many surveys, and the most adopted or most broadly used key value store around it. And probably you all know it as the default cache solution and session store. But it's more than that, right? Redis is more than that, and that's what we're going to cover in this webinar. My name is Guy Corland. I'm the CTO of Incubation in Redis, running all the innovations here in Redis. And with me, we have Ellen. She is a corporate solution architect. She will do most of the heavy lifting here. She will give you some demos and get you into the details and walk you through what you can achieve with Redis, different extension, and Redis in general to optimize the way you are developing your game. So, as I said, as I started before, Redis is way more than just a cache. Redis is currently used by all over the industry, starting from obviously web applications, e-commerce, search engines, finance, and obviously gaming. Every application that needs to provide a low latency experience to their users, meaning below 100 milliseconds, even way below that, right? If you have a game and your latency is 100 milliseconds, you're probably gonna have your users and players complain about lags and low latency and high latency. But if you want to keep your application way below 100 milliseconds, you need a special solution for that. You need a database that in most of the times will react under a sub-millisecond. If your database is not reacting in a sub-millisecond, if your database is doing 20, 30, 40, 50 millisecond latency, then obviously if you call this database more than once, you won't get into under a 100 millisecond latency, and your user will experience this long latency. And if you want to achieve like 10 or 20 milliseconds, obviously there is no other way than having an in-memory, very fast solution as Redis to provide your data. And you have to have a scalable solution, right? You have to have a solution that will also be able to serve your user, even if your requests are bumping from 5 million to 50 million to 100 million to 200 million requests per second, and you want to have a linear scalable platform. So with Redis and Redis Enterprise, and we'll cover Redis Enterprise in the next couple of slides, you can easily scale your application needs, just add more shards, and you linearly scale your database, and you can be able to serve more requests while keeping this very low latency of under 1 millisecond. But probably it's not enough, because if you are building a globally distributed game, and if you're not only targeting a single country players, and you want this online game to be distributed, then you need your database to be local, and you need to keep your latency local to your country. So if your application is deployed both in US, Europe, and India, then you need a database that can synchronize between these three sites. And you want to make sure that your reads and writes are stay on this low under 1 millisecond latency. And for that, you need a solution that can do that. And on top of that, you probably want to achieve more than just a simple key value, right? You probably have some social information that you want to store. You might have some time series data like monitoring. You have a stream of events. You have documents which are probably the user details or stuff like that. So you need your data types to be more versatile, and all of them to have this sub-millisecond latency, very fast database, very high throughput. So Redis is more than a cache, right? Redis and Redis Enterprise specifically is coming with much more than you might know about Redis. Like if you are already familiar with Redis, the key value store, then you're already familiar with the data types or data structures on the left. You get your string, your set, your bitmap, sorted set, hashes, or even you might have started to use streams, which is here for the last couple of years. But if you want more than that, if you want to have like a way to store JSONs in your document, or you want to have a secondary index and then query it, or maybe use some full text search, or if you need some connected data and a very fast graph analysis, then you need to deploy one of these modules. These modules are completely integrated into Redis. They just extend Redis with new capabilities, new data structures. They are available for everyone to use, including open source users. But when you using Enterprise or Redis Cloud, which I will cover soon, you will get all of them pre-packed in Redis, including data structures like Bloom filter, which allows you to do things like a top K, a very efficient top K that you might want to consider in when you do ranking. On top of that, Redis Enterprise offers many features that are not available as part of the standard distribution or any other cloud solution for Redis, that are really required if you want to achieve these scalable, highly available solutions, and maybe even reduce the cost if you are if you know that your data distribution. So that includes obviously a very simple way to linearly scale your database. Just by a click of a button, it scale out, increase the number of shards, and you still keep working with the same existing endpoint. It will give you high availability, durability. It will automatically take your snapshot persistently to the disk, so you won't lose your data even if a full data center crash will happen. And even if a full data center crash will happen, then you have this geo distribution, similar to what I described before, that allows you to get local latency. It's obviously also give you high availability. So even if the whole data center in Europe crash, your traffic from Europe can be directed to the US. Your user will still get full service. And by the time the Europe data center recover, you can move your user back to the Europe. So you are not only getting very low latency while everything is working and everything is local, you also can get disaster recovery deployment that will let your user always be available. On top of that, you get a couple of more layers of security. You are getting tiered memory access, meaning that if you're planning to keep hundreds of gigabytes or terabytes or hundreds of terabytes, it might comes to the point when you say, yeah, I love this very fast memory. It's becoming expensive because memory is a bit more expensive than SSD, right? So Redis Enterprise is coming with this tiered memory that allows you to extend into your local SSD. So either it's managed by us or on-premise that you deployed, you can extend your memory into SSD and just pay much lower than you might have paid for the RAM, right? Because now your memory is virtually extended into your SSD without impacting your performance too much. So this is why we call Redis a database, right? Redis is a database. Even if you are not using all these amazing features that I described before, then Redis has all these built-in features in it, right? It has replication, it has clustering, it has durability, it can store things to disk, it has automatic backup, and it has different layer of security. But when you get it on Redis Enterprise or on Redis Cloud, then you are getting it. For sure, you can consider it as a database because now you are not only limited by your local memory, you can extend into your local flash, and you get this active. So even if, as I said before, a full data center crash, you can still get your service on. So just show you some numbers about what are we doing here in Redis, right? We exist for more than 9 years. We have more than 5 million databases by our users that the Redis databases out there. We are deployed on about more than 500 data centers, cloud, on-premise, both. We survived more than 5,000 node failures, like machines that died on AWS, Azure, or GCP, but all of that across 200 data centers without losing any data if you kept all these mechanisms that I described before, like multi-data center replication, persistency, and stuff like that. And on top of that, you can see that more than 66% of our users are already considering Redis beyond cache, right? They are not only using it as a cache that can disappear in every moment and then they just refresh it, and they're using it as the front database to their existence, even as their only database, or the reference data, once they deploy it with all these different mechanisms. And last, just because we are in a gaming session here, these are 2 quotes that we got from different 2 gaming companies, My Team 11 and Entrax. And you can see both of them are using it as beyond cache. They are using it as their front-end database. They are relying on Redis Cloud, automatic failover, very low latency, by the way, failover, something that it's only achieved by Redis Cloud, because we know how to do this failover in a couple of seconds between if some of the machines are dying. And that's it. And with that, I'll give the mic to Ellen. Ellen, you can take it from here. I'll stop sharing.
Hey, thank you, Guy. Thank you. So yes, I will share my screen and start discussing use cases for gaming in particular. And so the title of our webinar is creating amazing gaming experiences. And so we can ask ourselves what makes an amazing gaming experience. And an important aspect of that is personalization. So here are some personalization aspects that can help drive player engagement higher. The first of those is detailed player profiles. They can drive many personalization aspects of gaming. The player profiles, the more detailed they are, they can drive matchmaking, they can drive analytics. Also, another thing is leaderboards. So leaderboards are also an important feature that engage the player, and for them to be of real value, they must be as real time as possible. Matchmaking, also something important. It has to be very quick, it has to be highly relevant, and any delays in the process can have a negative impact on player engagement. Social networks aspects, so the social network aspects of players can be also introduced into your matchmaking logic. And for example, you can have players who don't want to play with each other, so you can implement this blacklist feature into your matchmaking. And finally, measures and metrics. It's important to measure your player engagements, and using metrics such as daily active users or monthly unique players, things like this. And so we're going to show you how you can accomplish those things using Redis. First thing, player profiles with one core Redis data type, so Redis hashes. Redis hashes are simply a combination of key value pairs. And so you can see here simple example. So you have your username, you have your MMR. So MMR would be the matchmaking rating or ranking. So like the kind of the skill level of the player. Also, you have locations, so the player coordinates, which are very important to reduce latency in gaming. And then you have tags like group tags if your players are members of a group. You have blacklist tags if your players have blacklisted some users, and playstyle tags if you want to have games which match players with either like a disparate or a similar playstyle. You can use this information. And Redis hashes are very efficient data types because Redis is in memory. So we have to use very efficient data structures, not to spend too much money on memory. So with hashes, you can store over 5 billion of those key value pairs in one Redis instance, each with many key value pairs. And we have, customer with Redis Enterprise who store over 4 billion of those values. Leaderboards with sorted sets. So sorted sets are sets, so you have only unique members within that set, so you can have those members be your players. And for each of those players, you can maintain a score that would be the score of the player in the game. And those scores, they are ordered in memory, so that if you want to get your leaderboard to your top 100 players, you don't need to get your players and sort them. You just need one single Redis operations to get your top 100 leaderboard already ordered. Also, leaderboards, very efficient data types. You can store millions of entries with little memory. Redis graph, so is a Redis module that Guy has mentioned. And with that, you can incorporate some social networks aspects for your gaming algorithms. So this module enables us to take huge matrices and compress them down. So you can store those matrices in memory very efficiently, and that allows for very fast lookups. So you can go 2, 3, 4 hops deep in your graph, and you will not see a huge performance penalty. So for matchmaking, for example, it's a fast way to pull in social data without limiting the time to match. So a social network might look like this, where we have the user, Debbie Smith, who blacklists other users, and you can go several hops down on a millisecond latency, whereas with an SQL database, 4 hops deep might take you like 20 minutes if you have 4 million players. So it's a nice way to get network data very fast for your matchmaking. Measuring engagement. So that's also something that can be done with time series, which is another Redis module. And with Redis time series, you get the features of time series databases. So you can do indexing based on timestamps, you can do queries, aggregations with those queries, you can do downsampling, so implement aggregation rules and reduce your data and store data that would be the result of that aggregation rule. And so you can also integrate those things, those metrics that you create with Grafana or Prometheus and many metrics display system. It's really nice module for monitoring. Matchmaking, also for matchmaking, we can use Redis Search, another Redis module. And so Redis Search has features that all search databases have. So it has full text search, it has document indexing, so for your user profiles. It has aggregations, so find me a user with a level between X and Y. It has stem search, homophonic search. It also has geoqueries, which are important for latencies in gaming. And on top of that, you have features which are only in Redis Search. So the first of them is in-memory speed. So matchmaking, you want that to be as fast as possible. You want people to start playing ASAP to be more engaged. It has also fuzzy autocomplete, which is really fast. So if a player badly spells a username, you can still find the player for that username. And it's also very efficient data type again. You can store thousands of indexes. It's very light. And there are two killer features, according to us also with Redis Search. The first one is immediate indexing. So if you add a new user hash, a new player hash, it's immediately queryable because it will be immediately indexed. And it's the same if you modify that hash. Also, there is auto expiration from the index. So for if your player requests to be matched and requests to play a game, but suddenly it's logged out for some reason or changes his mind, then you don't need to manually go and clean your matching and your matching data. You can set a TTL for the index. So TTL is the time to live. And so you make sure in that way that after that time to live, your matching algorithms will include the data about that player. So here is I will show you an example of a Redis search query to find the closest point of presence to a player. So it's very important to find the closest server that will handle the game for a player to reduce latency. And so you can do this. This is the first part of the query. So we are doing an aggregation on an index called cities, and we want to load all of those cities, and that's the star here. For all of those cities, we're going to load two fields of our index, the city name and the coordinates. And then on all of those cities, we are going to apply a geodistance function, which will calculate the distance between each city and the player coordinates, which are here. Then we will sort those distances in ascending order because we want the closest points of presence. And finally, since we want only the closest and not see a display of all of the cities ordered, we were just going to limit our results to our top result. So let's say that now with that, we have obtained, we have gotten the point of presence, which is in Tokyo. So what we want is to find other players who have also been assigned to the point of presence in Tokyo. So we can do a search query like this. So we're going to search through all of our game tickets, so our matching tickets, and we will limit those tickets to the ones who are assigned to the point of presence Tokyo. And then the MMR, so the skill level, we don't want maybe the game to be too disparate in terms of level. So we can add this range condition for the MMR field of our index so that the level is uniform. Also, maybe we have gotten from Redis search a list of players that people have blacklisted that we don't want to play with. So with this minus here, we can just say that for the users who have the username with those usernames, that they will be excluded from the matchmaking. We also have optional conditions that we can add to a query. So for example, we can add an optional search for group tags. That means that the people who are in either of those groups will have a search score which is higher than the other, so they will come up first in the matchmaking. And we can do that also with playstyle tags. So we might preferably want to play with mobile player, for example. And so those conditions, conditional options are represented by this tilde here. And then finally, matchmaking. So it's not an isolated thing. Usually it comes after a matching request and before like a trigger to a point of presence server to start a new game with the match players. And so we've seen that usually things go like this. So you have a user who submits a matching ticket, and then the data of this ticket is enhanced with user profile data. Then we start looking for matches with our algorithms, and then eventually we submit also metrics about the matches that we found to a metrics display system. And then finally we queue backend requests to start games to our different point of presence servers. And so how can Redis fit into that? Well, first, you can use Redis streams to submit the matching ticket. And so streams there are append-only logs to which groups and consumer groups can subscribe, and with different pending and acknowledgements mechanisms to keep track of their processing by different services. And then you can enhance ticket data, of course, with your user hashes, and also with player hashes, and also with Redis graph data to incorporate some network aspects to that. Then you find your matches with Redis search, as we've just seen with a few queries. And with streams, you could submit your matches information to a metrics server that can use time series to create more pertinent and relevant metrics and display them in Grafana, for example. And you also would use streams to queue your backend requests so that they can be picked up by points of presence. So now I'll do a demo. And so what I'll do first is that I will create a leaderboard. So it's very simple. So I will use assorted sets as we've discussed. So now here I have a database running, a Redis Enterprise database running. And so I've connected to it, and I can just create my sorted sets with the command zadd, and I will name my sorted sets leaderboard. And then I just need to add a score for my first player and the name of my player. And I will add another player, and I will give him this score. And I will add 10 players total, and I will just copy and paste so that it's quicker. Sorry. Okay, so I have added my 10 players. Now I can just look at that leaderboard and see that it's ordered in memory. So I will use zRevRange because I want the highest scored player on top. And so zRevRange leaderboard, I will go from 0 to -1, which means I want all of the members of my sorted sets, and I want to display their scores. And so I will use with scores option. Now we can see that Bob is the first one. He's the highest ranked player. And we can see all the way down up until Thomas, who has the lowest score. And now, if I want to have my leaderboard, I just want my top 5, for example. So I will just do zRevRange again, the name of my key, and I will go from 0 to 4. So I will have 5 members of my set. And now I can see I have my leaderboard. I have my top 5 here. So I have created 2 scripts just to show that in real time with a bit more data. So this first script is just going to increment the scores of my players. So here I have the same players that I've just created in my sorted set. And I will just choose them randomly within that list. I will also select a random number, which will be the score, which will be their score. And I will increment. So with this command, which is the-increby, by which you can increment the score of a member of your sorted set, I will increment the score for that player by the number that was randomly chosen here. And here, every second, I will just use the command that we've just seen, zRevRange, from 0 to 4 with scores to display my top 5. And so we can do that now. So we're adding scores, players are playing, and here we can see in real time. So it's just one single operation that just fetches the data and it's already ordered. So you can see in real time that this changes. Now Ben is the top ranked player. So this is to show the leaderboard. I will just show you some matchmaking. So this is a simple board that I've created with Grafana. It's just going to show the number of matches per second and the total matches. So I will just start my matchmaking algorithm. And we're going to see those come up. Okay, it started. So we have 500 now. It's okay, 1K, 1.5K, and you can see that in real time. So you would be able, this is very simple metrics, but you would be able to also use time series to create some more pertinent metrics for your, depending on your use case, and display those with time series through a metric server. And so in that case, the metric server is receiving data from streams. So the matchmaking server is streaming to the metric server, which is displaying here. And you can see also, to show you the streams, here, this will be our backend where our points of presence will come and pick up the matching tickets because they have been matched and just start the game. So for now, I can just only see in Medan, but I have many per cities. And you can see, so those are our streams. They are coming in real time, and you can see the users that have been matched. And so the point of presence of Medan, the server, will come and pick up those tickets. And you can see them in real time. You will see coming in. Yeah, you have 2 new here in Medan. And here I have also Victoria and Urumqi, and you can see in real time those streams coming in. And so they will be consumed by our gaming servers. So let me just.
Thank you all for joining. Thank you, Ellen, for the session and the demos.
Yeah, you're welcome. Thank you, Guy, and thank you everyone for listening to us. I hope it was interesting.
It was great. Thank you. Bye-bye.